Checking the energy level diagram worksheet. I want to look at this first sample problem, and I'll have you make a couple notes down here in the bottom. What wavelengths of light are emitted when an electron jumps from the second level to the first level and between the fourth and third levels? So we have to look at the energy diagram to get the energies from each one of those levels. So they want the second and first level. I'm going to read those numbers off the energy diagram. And then H and C's are constants. We have Planck's constant and the speed of light. So this is the example problem that they gave us. And recognize that 10 to the minus 7, when we're talking about wavelengths of light, this is 122 nanometers. I also notice that I have 3 different constants that I'm using. Planck's constant, speed of light, and this is a conversion between EVs and joules. So there's a shortcut we can use. Looking at the formula, we have H times C. On your formula sheet, there is a constant called Hc, and it is there specifically for these problems. There's 2 constants because one of them is for energy in electron volts and the other one is energy in joules. So plugging the numbers into the formula, I like to use the 1240 constant because not only do the EVs cancel out, but they're already converting to nanometers for us, so we don't have to do the engineering notation conversion. All right, so first problem, using the new shortcut formula. I'll also point out on your formula sheet, they list this constant as 1.24 times 10 to the third. It's 1,240. I don't know why they write it that way. To me, it's a waste. Just write 1240. All right, so here's the first one. On the back side, this is the proper drawing for the energy level diagram for hydrogen. The ground state of hydrogen is 13.6, and we think of this is just the work function. It works just like the photoelectric effect. It takes this much energy to eject an electron from this energy level. And if I give it more energy than that, let's say I hit it with 14 electron volts, then I'm going to eject this electron, and the difference between those 2.4 electron volts will be kinetic energy for that electron. You need to be very careful, though, not to use the word work function and not to use the word photoelectric effect or the photoelectric effect formula when we're solving any of these problems, because you'll get marked down for it. I have labeled the energy levels for 1, 2, and 3 on here. Practice exercise 8 says calculate and label the energy levels for N4 through N7. So we're going to use, this was the equation that Niels Bohr had come up with to calculate the energy level for each one. Z is the atom number, so hydrogen is atom number 1, that's easy, and N is the energy level. So N1, 1 over 1 in this formula, we get 13.6. When N equals 2, I'm dividing this by 4, so divide by 4, I get 13.4. Dividing by 9, I get 1.5, and so forth. So for the next energy levels, the 4th energy level, you're dividing by 16. The 5th energy level, you're dividing by 25, and so forth. All right, so these are the other energy levels that continue on up here. The reason these are all labeled as negative energies is because it's energy you have to add to the atom to release the electrons. Some of the books label them just as numbers, as positive numbers. Some do it as negative. It really doesn't matter. Number 10, use the hydrogen energy diagram that you labeled. Those were the numbers that we just figured out to find the wavelengths for the Paschen series. If you bothered to read the front side of it, you would have seen that the Paschen series says electrons jumping to and from the n equals 3 level. So they want to go from n equals 7 to n equals 3. Those are 2 energy levels. So plugging in the formula, we're subtracting the 2 down on the bottom. On the bottom, I don't pay any attention to the negative signs. You just need the difference in the 2 energies down here. This will be the wavelength of a photon that's absorbed in order to get the electron to jump from the third level to the seventh level. When the electron jumps back down from the seventh level to the third level, it will give off the same wavelength of photons. So we use the same formula to calculate each one, and you're not going to reverse these two and call one of them negative and get a negative wavelength. That doesn't make any sense. You're just finding the difference in the two energies. So don't pay any attention to the minus signs on there. All right, so the next one, we're going from the second state to the third, fourth, and fifth. So we have 3 calculations to do. And again, I'm using my EV nanometers HC constant. That way I get all my answers in nanometers. And you should recognize that these are all within the visible range of light. The next one, they're giving us a wavelength of photon that's being absorbed, and they want to know between what 2 levels. So we'll first calculate what the energy difference is using the formula. And then we're going to look at all the energies that we calculated for all the levels and figure out which 2 numbers am I going to subtract to come up with 12.7. This is the closest one from energy level 1 up to energy level 4.